Hello and welcome to Noman for another industry event live at the Dell stage. Fantastic, love the enthusiasm. Thank you all for being here, and thank you for tuning in at home. I'm your host, Chris Hawley, social media manager here at Noman. And before we get started, if you're looking for closed captionings, please head over to our YouTube or our Facebook page. We'll be able to take care of you there. The other thing that we want to make sure that we always say every time we have one of these fantastic events is we wouldn't even have these fantastic events if it wasn't for our sponsor, Dell and NVIDIA. So thank them for bringing us tonight's amazing event. So, tonight, we're excited to welcome Eleazar Kim-Carmeli and Lisa Hong from Jakks Pacific. They will be doing a really cool presentation and a demo and a Q&A. Their presentation will explore how traditional sculpting and art education inform modern 3D workflows. You'll also learn about Jakks' creative process, the tools they use, and what makes a toy successful from both an artistic and functional standpoint. Be sure to stick around until the end of the presentation. We'll do a Q&A. And if you're watching online, you can enter your questions in the chat there, and following the presentation we'll be raffling some stuff. I'm not sure, is anyone interested in getting free stuff? Anybody? Okay, cool. Awesome. Oh, dang, even more applause. You can't see the hands at home, but there were a lot of them. So everyone here and everyone at home, please help me welcome Eleazar Kim-Carmeli and Lisa Hong.
Okay, good evening everyone. Thank you so much for coming. I had to walk around the school earlier. I was so impressed with the clay sculpting department. It reminds me so much of my own education. It really makes me happy to see a place still doing such important training. I am director of sculpting over at Jakks Pacific Toys. We are one of the 10 large toy companies in America, and in my opinion, the best toy company in the world. This is Lisa Hong. She's senior sculptor on my department.
Hello. Hello? Okay.
So here's a quick look at some of the brands we have. We work on a bit of everything in my departments. So a lot of stuff. So let me give you a quick overview of what I'm going to be talking about, my own road to how I got here. I attended Lime Academy College of Fine Arts in Connecticut. It's a traditional art school that isn't really around so much anymore. I worked with Dr. Fresh, worked with Mattel, and now I'm at Jakks Pacific. Altogether, just under 20 years that I've been in the toy industry, so seen a lot of change that time. From back in the day, we do everything by hand, to now we're doing things almost entirely digitally. We still, though, 3D print everything and look at it and review it because we make physical objects that people are gonna play with, and that is probably the most important thing to always consider with this type of sculpting. Someone is going to hold it, they're gonna look at it. So it's not just what you see on the computer. My background, like I said, was Lime Academy. It was a very, very traditional school. That's actually the founder of the school there. Amazing school for ultra traditional. Didn't have a single computer in the place, but very in-depth into traditional sculpting, and everyone in the sculpting department, as far as professors, also worked commercially, because in the 20th century, you couldn't really do fine art. You were going to be doing toys, you were going to do cemetery headstones, or you're going to do movies. So it was a given from the beginning, you have to learn commercial. That's most of my own work, class 2003. One of my first commercial companies I worked for was Dr. Fresh, and that was hand sculpting prototypes, both little miniature figures and bottles. In fact, the bottles you see there on the left, those are still in production today. They'll use other types of products on them, but it's kind of funny to me. I'll go to like Walmart or Target and still see them, nearly 20 years later. This is some of the stuff that, like I said, was hand sculpted, usually in castelline, and then we'd make a mold and cast it into a resin, polish that up, send that off to the factory, and they'd use a pantograph to actually make the molds. And I'm just a little curious here. Who here has seen an actual three-dimensional pantograph? Can I get some hands? Well, I'm impressed. I saw one. Yeah, that's something you don't see so much anymore. But back in the day, that's how everything was done. You'd have this thing that would copy what you sculpted into steel and just cut it out. This one toothbrush right here, it's a light-up Spider-Man toothbrush. Little tiny 1-inch tall figure on that. One thing I'll definitely say about that company, Dr. Fresh, they punched above their weight. They were competing directly with Procter & Gamble, and I think it was about 30 million of those sold. And when I think as an artist, you want your work to be seen, for me, that was kind of an achievement. It's like, hey, 30,000 people got to see that. They don't know who made it, but at least it was something. So when I went to Mattel, I got to work on a number of different products, everything from wheels to Barbie to action figures like DC stuff. You have to know a lot of different programs. You can't be locked down to just one thing. So for instance, this is stuff that is done in Pro Engineer. This is for the Hot Wheels and Matchbox. So I actually had to sculpt these directly into Pro Engineer, which if anyone's seen Pro Engineer, I believe they call it Creo today. It's basically sculpting with math. We'll just leave it like that. This was an action figure I got to work on for the DC stuff. One of the things, reasons why I put this in here, that base figure was actually sculpted by a friend of mine who's manager over at Mattel, Sean Omos, incredible sculptor, and had a great deal of influence on my work. When you work in toys, it is a collaborative type of business. You're going to work with other sculptors, you're going to work on top of the work, and especially as a young sculptor coming in, it is the best way to learn things. His work was so influential on my own. I always look back on this. This was, I believe, Ever After High. I did all the accessory work on this, and this was actually sculpted on top of a figure by Adam DeFelice, who's also a sculptor at Mattel. That guy, incredible sculptor as well. One thing he always said to me, everything he does, he tries to put an arabesque into. That's a type of geometric form. Another way of saying it would be to look for rhythms. When you make a sculpture, it's very easy to make something stationary and very stiff and boring. And especially with action figures that you're going to be posing, you kind of like, oh, I'm just going to have them in the A pose, and there we go. But this is something you want people excited to really get their hands on. A little bit of rhythm, a little bit of arabesque into something goes a long way. Highly detailed work. Of course, in Mattel, we do all kinds of crazy stuff there as well. So this was, I believe, Cinderella. And this was about 5 inches tall. This, of course, had to be manufacturable. So every detail you see on there is to spec, meaning that everything is done to the proper wall thicknesses, proper heights and depths. I know that our tooling can't go below 7/1000ths of an inch. So I know that our wall thicknesses can't be below 65/1000ths of an inch. Everything has to line up and it has to be machinable. It's another fun one. Did a lot of vehicles. I think at one point I was doing as many as 120 vehicles per year for between Matchbox and Hot Wheels, which is average. They do a lot. And actually, I'll tell you right now before I move on, the hard part of any surface vehicle design is going to be the A-pillar. That's going to be that part right where the windshield meets the hood. Doesn't matter what program you use, I promise anyone who's sculpted cars, your A-pillar will drive you crazy. That was the Justice League movie, Batmobile. This was a fun one. This was sculpted in the program, which I'll be demoing soon, called Freeform. This one actually, they didn't have time to give us an actual model to work off of, or even photos. They actually had the designers go out to the movie set with a bunch of Post-it notes, come back and give me just a mess, and said, make magic out of this. This thing was, I want to say, about 28 inches all the way, front to back. little inside baseball, when we made this prototype, the motor was so powerful, I believe it did something like 40 miles per hour. They had to like turn it down, or else if it hit a bump, it would just vanish, it'd just be gone. Minecraft minis, I actually sculpted 22 waves of these, all of which in Pro Engineer. 3 series, which is, God, what is that, 16? So 3 of those series of 16 I did in Sweden in front of the Mojang team over the course of one day, which was a lot of work, not a lot of fun. So coming over to Jakks, took over their sculpting team to start doing just a wide variety of stuff. One of the big things we did, that I did with them, was the Apex Legends figures. These are highly articulated figures with a high degree of detail. One of the fun parts about this type of model is that you're going to be working with a licensor like Respawn. They have some amazing assets, but those assets aren't necessarily manufacturable. Mostly because they're going to be using all sorts of tricks to make it run on a game engine. Things, of course, like displacement maps, texture mapping, low polys type stuff. That does not translate to toys because there is no cheating in toys. You have to cut this thing out of a block of steel. So if you have a 100,000 poly item, it's going to show up as a 100,000 poly item in the mold. So you have to do a lot of resculpting. You have to look at each detail and decide, what is it that I can actually make? What is it that I have to do as a tampo? What can I resculpt to put the detail back in? What do I have to sacrifice? This is one of the other ones. This one was a lot of fun just because trying to get those legs to move in just the right way. And also one very important thing when you work with licenses is trying to represent that license appropriately. Whatever it is that you're doing, they have to be able to do these iconic poses. So, when you sculpt into a toy, can it do that? Can the end user enjoy this for what it's supposed to be, what their icon of what it should look like be? Some fun things we did with them as well. These more original little minifigures of Apex Legends. Actually, a lot of these mixture between ZBrush and Freeform. One of these, actually, I think the majority of these designs were done by Jeff Matsuda, the comic book artist. And I've been a big fan of him since I was a kid. And I so desperately wanted to meet him, to give him some of these, but unfortunately it didn't work out. But still was an honor to be able to sculpt stuff from his illustrations. More vehicle type stuff, and in this case, it's also getting a bit of functionality into it. So it's not just a car, but how does this car play? How do we blend those things in? We did a lot of back and forth on these. So for example, on the next one, see, this is the base model before we start cutting it up. If this car was in front of you, you'd be like, my God, why is it so tall? That's because in order to get that mechanism in there, we had to raise the roof a bit. So you gotta learn how to fake things sometimes, because this is a 1/64th scale. And you look at any 1/64th scale car, you go to anywhere, any store, look at a Matchbox, Hot Wheel, other third-party car, one of our stuff, and you just imagine, take a tape measure, measure that wheel, multiply it 64 times. That is not a 22-inch wheel, that is a 40-inch wheel. You have to do all sorts of changes at that scale to make something look appropriate. This was a lot of these minifigures that I did for the Encanto movie. It was also during COVID, so of course getting samples done was very hard. So in this case, it was also what we call virtual model. That's where I not only sculpt them, I digitally paint them and render them in Maya. In this case, I was using Arnold Render Engine, so that way we could get something that we could use for our marketing. There's more Harry Potter stuff, kind of the same thing, virtual model type stuff I did of these sculpts. This is one of the prototypes we had done. It was actually a very fun one to interpret the design of this character from Harry Potter and kind of reimagine it to something. This is actually one of my favorite ones that we did. It's the original IP. It's from our BAM series. I will tell you, oddly enough, I have done a lot of screaming werewolves in my career. I don't know why. But this was one of my favorite ones. The artist on this one, Cheeto, that did the illustration for it, loved working on his stuff. So when I got to do this, it was just one of my favorite things. It's another one, and another screaming face. But yeah, super details from our BAM line. Mario, the Mario movie. This guy was a lot of work. It paid off because it was one of the best-selling toys of the year when it came out. One of the things that was really so important with this one is that you have to interpret not only the design from Nintendo, from the movie, and then also make a toy that people can enjoy. And that was something that was really important for us when we were working on this, and especially for me, is that I wanted people to be able to pose that character into the right poses, just like what they saw on the screen. Sonic, this is from the Sonic 3. So I worked on the Sonic 2 movie toys and the Sonic 3 movie toys. Just so you know, that fur on there, when they do the actual movie, they're using, of course, particle and curve-driven fur effects to do that. That does not translate into toys. You get none of that. So you have to resculpt it. And in this case, they had a very specific design that fur had to look like. So I was given the reference of all the renders, and I had to match it. And each one of those strands of fur, I sculpted by hand individually, to the point where I had to ice my shoulder that evening because it was just that much work. This is from our Alter Beast Sega franchise Wave 2 series. It's actually one I really enjoy because it has a very, very high degree of articulation. Don't often get to do things that aren't people, you know, with like, for instance, dragon wings and tails and stuff, and try to figure out, like, okay, how can we get some fun articulation with this so that it can do those poses that what you see in that video game. And bendy. So I got to do a lot of these bendy figures, and one thing I want to talk about with this specifically, before we did this, someone else had a bendy license, and I wanted to make certain that when we did this particular license, it was of a level above. So when you see these figures, if you go to articulate them, they're a clean articulation. You don't have weird cutoffs. You have a figure that represents as close as possible to the video game, so that when you see it and when you go to play with it, what you see is that character. You see what that license is. You don't see, well, they had to cut it here because they didn't know how to do the figure's articulation, or they thought the mold wouldn't look right, so they just drafted it out. To me, what makes a good toy is you don't see the molding. You don't see the engineering. You just see that icon, that bendy figure, that whatever it is. Lisa? So.
Hello, everyone. My name's Lisa. All right. So my name is Lisa. I'm a senior sculptor at Jakks Pacific. I'd say my journey is a bit non-traditional. I started with a BA in psychology from UCR. Woo, Highlanders. After graduating, I was like, I worked a couple of jobs, office work, insurance, print shop, and eventually said, yeah, this ain't it, so I'm going back to school. I went back to East Los Angeles College, ELAC, and from there, I kind of discovered the world of 3D, and I kind of never looked back. So there, I did a lot of self-teaching. There was a few teaching opportunities, and eventually, I finished my AA in animation. After that, did some freelancing character art and landed a role at Jakks Pacific. So what do? I've been in the toy industry for about 3 years now. Most of the projects I work on are for Disney, Girls Team, and the occasional Boys Team support. So here are some samples of work I've done at Jakks. Here we have the Disney Princess Wand. Bunch of kind of detail and relief work in the back. These role-play jelly shoes for disguise, which is also for Jakks. For Disney's Wish, the Asha's Secret Wishing Journal, the texture was a pain. I think I crashed Freeform a million times making this. We have for Moana 2, the Matangi from the Moana Petite set, and oftentimes when we think about toys, it's not just the dolls and the action figures, there's also the other, accessories that come with it, right? So we have a feather choker situation, the bat, and the headband. Okay, so we have the accessories that I've worked on for the Disney Illy Forever fashion doll. This one's inspired by Mickey Mouse. So we have the little tiny, tiny bags, little tiny sunglasses. And last but not least, we have, for our Shelf Talkers brand, the dude from the Big Lebowski. Alrighty, so for my part of the presentation, I'm talking about interpreting design, right? The example I'm going to use is the wand and headband, specifically for the Disney 100 Tinkerbell doll. So first of all, let's talk wand. As a sculptor, right, your role is pretty collaborative, right? You're bringing another artist's vision to life. It's their vision, and you have to interpret what they want. And you're trying to always balance between aesthetics and function. Here we have some images of the a revision process. The orange arrow is pointing to one of our original reference drawings, our very, very first drawing. And the images, the two wands next to it, are some of the process and different versions we went through. There's more, but I couldn't find them. So, and to our right, we have a little example of what kind of feedback or notes you get from an artist. So the red lines indicating shape changes and adjustments, little reference images, about how these stars should look like. They're like little things here and there. And sometimes you get fun notes. On the top, you get something like less ridge, more star, as opposed to, I guess, more star, less ridge. I don't know. More ridge, less star. All right, so designs, right, must maintain their form while adhering to specifications, tolerances, and functionality. So specs now, we have some changes now. We want to have this wand light up now. So we want to fit LR4 for batteries inside this wand, the handle. So some Googling, you'll find out that this one button cell is 0.47 inches by 0.21 inches. And you'll have to build around that, right? Those dimensions can't change. So we have to maintain a wall thickness about 65 thousandths of an inch. This number will keep popping up over and over again. And we'll have to also, have a minimum tolerance for details to show up in production about 15 thousandths of an inch, .015. We'll elaborate on that a little more later. So right here, right now, we have our final drawing, final drawing. And here's some, our final sculpt. And our final product. All right, so one more, headband. So this is one of our first, I think this is the only drawing I got, the original drawing I got for this headband that we worked on. So for the workflow, what are we blocking out? Break it down to individual elements and ask yourselves, what are my dimensions? What are these specs, what are these requirements that I have to follow first? So first of all, it has to fit the doll head, right? So let's get that down. And don't forget to account for the hair between the headband and the head. And here comes the magic number, 65 thousandths of an inch again. It has to be thick enough for it to hold all the elements on top. So I also think that this headband is actually a little thicker than that. It's probably closer to 0.07 or 0.08. So how do you balance detail on a small scale while meeting production standards? So let's break this down together. We're only going to focus on this center flower here. So there's this, right? There's more. And there's piping around each of these petals, or so it seems. And more detail. There's a lot going on in this one flower. But will these details fit, though? This is a question you have to ask all the time when thinking about making small objects. The main flower itself is about 1.5 inches all around, 1.5 by 1.5 by 1.6. I know a lot of numbers, guys, sorry. And here comes our number again, minimum tolerance about 15 thousandths of an inch. So eventually we decided to revisit this design because that's just too much going on. So what we have on our right is our final image. As you can see, there's, very simplified, less layers, only 5 things on there. So there's a pink layer, a yellow, a red, an orange, and a violet. And notice that the pink, it's also the same layer in the center. We're trying to minimize things. So let's elaborate on this 15 thousandths of an inch thing. Okay, so let's close up here. Each of these spheres here represent 0.015 inches. And in whatever sculpting program you're using, to check on that sometimes, you can make a sphere of that size, put it up against these details, your raised surfaces, the grooves, and check it. Now, if it's greater than the sphere, then you're in tolerance. We're good, right? Some things to consider. You can vary the depths of the details. So this colorful image here, if you can see that each of the depth of these layers are they vary compared to our reference spheres. There's also slight subtlety in the curvature of our layers, especially the pink layer, right? There's a slight lip that curves upwards. And these little things kind of help add to the depth or the look of our sculpt. It helps catch light and shadows and creating a more illusion of depth. And then we think about these things because they're working on such a small scale. You're trying to get everything you can. So here's our final sculpt and our final product image. All right, cool. Thank you.
Okay. Thank you, Lisa. So a couple quick things about how toys are made. They are going to be cut out of a big giant block of metal in a big machine like this. This is actually, I believe it's a 5 or 6 axis Haas. It's a very nice machine. So they have to cut this, and they actually have to cut several blocks of steel, and they have to go together in what they call a tool, and they're going to be injecting plastic into this. So when we talk about these numbers, these wall thicknesses, in this case 65 thousandths, 15 thousandths. So 15 thousandths is going to be the diameter of the end mill bit that's going to cut that steel. That means if it goes below 15 thousandths, it's not going to get there. It's just not going to happen. So that detail's gone. You can EDM things down to, and you're pushing it around maybe 7.5 thousandths on the radius of that bit, but realistically, it's not going to happen because plastic has what's called exothermic shrink. It's going to shrink down, so they'll usually scale things up before they cut them, sometimes 2 to 3%, but things soften. So that's why we have to hit certain numbers when we make things. Real quick. So when I talk about the different types of molds there, so CNC is kind of a standard thing. You're going to see that a lot. Rotomold, that's a plating technique. That's what you do for doll heads, for instance. That's in the polysol material where you have that squishy head. I'll show you guys what that looks like shortly. Beryllium mold is a alloy. It's actually a copper alloy. You don't see it as much anymore. It actually was a casting method. And then, of course, you have blow mold, which is actually CNC tooled, and they actually heat up what looks like a little beaker, and they inflate it into the mold. You see that mostly for bottles, but occasionally you see that in toys for certain types of shapes, usually big stuff like you have a kiddie pool, for instance. That's something that may be blow molded depending on what the shape of it is. So these files are going to be tooled in a CAM program. This is actually, I believe, a Creo CAM, and this is where what you're seeing there is the tool paths that it's got to run that end mill bit on. They'll usually do what they call tool changes. So if you look on the left, you'll see that they have different types of things on different axes. That's because they're switching out the tools to either smaller, or to a drill, or to a different thing. All this stuff is stuff that we have to consider in toys because how we make something will affect how they tool it. If they can't pull it on an A-B mold or a two-piece mold, they're going to have to do slides. But slides, that's where you have a mold and you have parts come out this way, and then you'll turn to the side and you have one sliding out. But you can't have more than, I believe, but I've seen 4 slides, and that's pushing it. Usually you want to have 2 slides, left and a right. You start going on weird angles, your tool gets huge. And then also you can't have that many cavities. You want to be able to get as much out of one mold as possible. So all that stuff comes into effect in how we make things. Now detail, like I was talking about, that minimum detail 15 thousandths down to 7.5 thousandths. If it goes below that, you have to do something called laser etching. That's what this is. They actually laser etch this into the steel. Here's some examples of the molds I was talking about. So on the left over there, that's a beryllium mold. This is actually a cast beryllium mold. It took me a little while to find a picture of that. You really don't see any of those anymore. I used to see those for PVC molds, especially like action figures. You get a slug of something because they cool so quickly, it allows the plastic to shrink away so you can pluck it out even with an undercut. That's like a big 2-piece mold right there. This funny looking head right there, that is a rotomold. So that's actually made by cutting a piece of wax, dipping it into plating solution, and they'll leave it in there for like a week until they get a 65 thousandths wall of copper on there. And they use copper because it's going to heat up very quickly and then cool very quickly. Okay, and let's do a demo. So, I'm going to just pull up the Freeform. Sorry, I just gotta get over a little bit. Okay, so before I get started, I just want to see if you guys can see this. So this is a haptic arm. This is the tool that we use with this program called Freeform. In this case, this is Freeform Plus 2025 edition. So this, like I said, is a haptic device. So that means that I can feel everything that I touch. I'm going to feel resistance. I go to sculpt something, it's going to actually push back a little bit. I can carve into it. I can set my tool to very specific sizes. So this is a carving tool, for instance. And I'm just going to put a block here. And let's just set a resolution. Okay. And grab the carving tool. And right here, that tool size. So if I want to do 15 thousandths, that's 15 thousandths. I know exactly what that is. Part of the reason why we use a program like this, it being voxel driven and actually very unit driven, so it has exact measurements, is very important for our manufacturers. I was talking about with our wall thicknesses, 65 thousandths, 15 thousandths. That's specifically for ABS plastic. Different plastics, you're going to have different types of settings. I believe PP, you go up to 75 thousandths. I believe more on the PVC, you can go down to like 55 thousandths, have it tapered down to 35 thousandths. So there's a lot of numbers involved in this that we have to consider when we sculpt things, so we don't just make something and call it done, because if you don't have your numbers set, if you don't have all your details to spec, what's going to end up happening is the engineers that go to tool this are going to have to fix it for you. And they're damn good engineers, but their job's engineering, not sculpting. So they're not going to be making the decisions that an artist is going to make. So you got to make certain you make those decisions for them. So let me just pull up a haptic file I want to show first. I'll show one of the features of this that's kind of fun. So this is a box with a slot through it. And if you guys can see how the arm's sitting there, when I talk about haptic feedback, see that once it's slide now all the way through there, it can actually feel exactly where I'm moving it if I'm running it into things. So it has actual interaction between stuff. So here, I'm just going to put this like that, and then just the arm will hang there. It has a bunch of motors in there that hold it into place. Let me go ahead and pull up one of our files. Let's start off with a link from Breath of the Wild. Personally, this one was a very fun one for me. I remember playing the first Zelda game when I was a little kid and wrecking Ganon, so I was so happy to get to sculpt this. And it was also very important that this represent the character in the right possible way. When you play the game, it is a cell-shaded character. It is a low poly model. So to take it into a 5-inch figure so that it can actually articulate well, have the right details, and be able to pose in a way that the end user, they're going to be able to enjoy this without seeing, oh, this is limited because of that, or they didn't sculpt this detail because of whatever reason. So for example, these arm wraps here, I had to go through and, oops, let me go and pull that in the camera. I had to go through and individually sculpt every single one of those, and each one of those to spec, so that way when it's manufactured, you can actually see them, and it's not just a blurred out detail, because like I said, this is a 5-inch figure. Same thing with like the hair detail, and even all these details into the clothing. Each one of these folds is at minimum tolerance of manufacturing. The little stitch details are within the tolerances of manufacturing. So in this case, I actually ended up pretty much resculpting this guy from the ground up. Let me show you a little bit about the articulation. Let me just turn off the colors on that and get to my pose tool. Just got to put that into our favorites. So one thing that's really nice about this program is it allows you to do things called pivots. They call it pose here, but each one of these pivots allows me to actually set a pin just like we would in reality with manufacturing. So I know each one of these pins is at least between 65 to 100 thousandths. I usually try to hit like 100 thousandths on a rod there like that, just because when you have an arm or a leg, you got a nice big fulcrum, and you come to that end of that fulcrum, or you're a kid playing with this, you will snap that arm. So the thicker you can make that rod, the better. This program allows us to set pivots and then to actually rotate it, check our clearances, see where we're running into things, see if it's at our limitation of like, well, you know, you're going to be hitting there, but I don't need it to go too much further. How about there? And I can always snap back. Or I can move it into place and I can actually go through, in this case I'm going to grab this arm and adjust the sculpt. Come back to my rotator or my pivot and be able to check and move it. I can also go through and do offsets. So in this case, it's this part. I'm going to say, all right, let's go utility, let's go create an offset. And I'm going to create an offset of 4/1000ths of an inch, because I know that is my manufacturing clearances for this material. That varies for material. Some materials, they're going to say, oh, we need 5,000, some they need 3,000. Sometimes they'll have you do it at net fit. That means 0, depending on what it is. So we work with our engineers, we work with our factories, we get to understand what each manufacturing is going to be so that we can hit those exact details. If you look on the down at the bottom of the screen, it's doing its progress. It's doing a precise offset at that number. And now I can actually take this and do a Boolean. And just pick out whichever part that is, which that is the right forearm, and subtract it. And as you see, it already cut that. So then I will go through and clean that up and make sure that's a nice clean shape so that in manufacturing it looks good. One thing you'll see in my files, everything is labeled. And sure, as Lisa can attest, I am crazy about this because I will check other people's files. Did you name everything right? Because if you're going to be handing this off, like I said, to an engineer to be manufacturing this, they got to be able to find each part. So everything has to be properly labeled. So let me move on to our next one. Ultra Beast. Another screaming werewolf. So This one was a bit of a challenge originally, just because if anyone's played that game, you don't really get a straight-on shot of what this guy looks like. You know, it's an old Sega game, it's very interpretive. We worked a lot with them to make certain it looked right. The last thing I wanted it to do was look like a guy who woke up naked in a pet cemetery. Once again, all this fur is individually sculpted because I hate myself, and each of it is to spec. In this case, because I knew they were going to be using a PVC material, and I knew I could push the detail. So this is actually down to that 7.5 thousandths of an inch, which is pretty slim, but I knew in the manufacturing it came out. This is one of our figures. We had a much higher degree of articulation. We started doing these butterfly shoulders, which I absolutely love because you can get really dynamic poses with these. Because once again, what makes a great toy is you go to play with it and you don't see the engineering, you just see this great character that you can enjoy. One thing I really recommend to anybody who wants to get into toys, play with toys. You know, I'd be ashamed if I didn't play with the toys I made. You know, would you go to a butcher who doesn't eat his own sausage? Would you, see a doctor who refuses to get his own medical advice? Of course not. So you should believe in what you do. As you see, this is a very articulated figure. I'm going to show in a minute just kind of how we do these pivots and a little bit about these details and some of these stuff, but give you an idea of this. So when I go to figure out all this stuff, how far can this move? Where does it start intersecting the things? Where do we find the limit? So the designer and myself will look over this stuff, and he will say, well, can we push it a little further? Can we get a little bit more articulation? What is the sacrifice? Are we going to have a bigger opening? Are we going to have to do more parts? Do we have a worry about the strength of the model? All that stuff comes into play, and we will go over it over and over again and do 3D prints and check it out and see how it works. One thing we use for this type of model, we'll use actually a Stratasys it's a polyjet printer. So what that means, it's kind of like a wide format printer, but prints in 3D into Jello. And that Jello is water soluble. So that way we can actually get an idea of these joints without having to assemble it. We just wash that Jello off. And then once we have a really good working articulation, we'll do a different type of 3D print to get an idea of how the final model is going to look and how it's going to work. And we'll do our paint masters and all that fun stuff. So just turn this off so you can get a look. So I'll go through and I will run these joints every which way and work with our designers until we get something that is matching up with the level of articulation that we want to hit and also still looking right. Okay, so this is actually a non-licensed thing. This is what I call a blue sky figure, or blue sky project. Whenever I'm trying to work out new articulations for something, I'll just pull up something non-licensed and just part it out so I can figure out some sort of new joint or new design or new type of toy that we want to work on. In this case, we're playing with some different types of joint designs, so that's what this one came out of. Similarly, there are articulations with these pivot points. So when I'm working out what all these joints are and what type of articulation I can get, what type of poses I can get, if it looks good or not, that's kind of where all this comes in. And let me show you a little bit about what that workflow process is like, and as well as a few other features with this program. So it's just the arm. And I'll go through and I'll figure out, okay, what angle do I want to be chopping this up out of? Where am I going to be seeing that articulation points coming to? And then I'm going to be putting drawings into place. So in this case, let me get to my drawing plane. So right here, 100,000ths of an inch. See how they're touching right there, but they're not intersecting into each other. So that way I know it's not going to actually get stuck and locked into place. It actually is going to rotate. I will figure out clearances after the fact. Right here, these distances is where I'm working out where that stop is, because I want that arm to stop and not keep going all the way around. So to give you an idea, we'll use tools like, for example, I can use this as a select tool, so I can go through and select my clay. That's actually what they call it. Instead of a mesh, they call it clay. Let me get both sides. And in this case, I'm just going to copy and paste it. And then turn that off, so I have a nice clean cut of this. And I'm going to move to the side. So one thing that's nice about this program, these planes I put in that I draw on, I can set a plane anywhere. It's going to stay there, and I can move it, but I can always come back to it, and I can look at it, and I can rotate 90 degrees to the front of it. And that's really important, because if I'm going to be figuring out what the thickness of this guy is, let me make certain there we go. So I want to have the slots for this at a certain diameter. And oops, let's go back to that one. So I set this one to 100,000ths. And I'm going to do a cut this time. Just keep that. And give you an idea of stuff, let me just show you a little bit more. So this is where I did the same process, except for instead of selecting the circles, I selected this section here. And I cut out this section from there. So what I end up with is this, and this is for that elbow socket. So now I have that elbow socket design. And let me show you what some of these pivots look like when they're in place. So in this case, I have what's called a double elbow socket. And then I can do my offsets for each part. So for example, I can go through to this elbow, which is, you know what? I'll just select it this way. There we go. And let's do an offset, create offset, 0.004 of an inch. And boolean remove from. See right here, filter hidden objects. That way get rid of everything I don't want. Subtract it. Do it again from the other side. Subtract it. Oops. Put this back into place. Because I have the wrong one on. All right, there we go. Now I know it has its clearances, so that way it can function. That's a little bit basic of how we'll figure out our joints. And we'll do very, very different types of joints, insert joints, ball joints, other types. We all use the same process, figuring out what these offsets are, figuring out what these cylinders are, make sure that everything's to tolerance. Now, a little bit on some of the features of this program, what makes it honestly so special. Let me just go, no, we'll just make a, yeah, let's start with a cylinder, like working in inches. So, you know, the box. That's cool. Okay, So, like I said, it is a haptic-based program. It's also a voxel-based program. So, voxels are volumetric pixels. It's similar in a way to the way 3D Coat or ZBrush works. I believe ZBrush calls it pixels, but they're voxels. One thing that is kind of amazing about voxels and the background of it, voxels have a predefined dimension. What this program does is, what all programs do, is they scale the world of that voxel to meet a unit of measurement. Now, programs like ZBrush and other ones will do that on the export, or they'll do it behind the scenes, an export and an import to get proper dimensions. Whereas in this program, Freeform, I can set the dimensions as is, and I can have multiple different resolutions, and they all will be respective to one another. So to give you an example of that, I'm going to make torus. Let's do this. Let's make it much finer. This is .0787. Let's do fine detail. So these are much different items. This is a very low resolution, so this would be actually a relatively small world with big voxels, and this would be a big world with very fine voxels. But they can intersect with each other without having any type of issues or inaccuracies. So let me just go ahead and do a Boolean to show you an example of that. So coming back to some of those details and the measurements we were talking about. So let's go ahead and throw a few curves on here. So when you go to do things like, for instance, cut lines on a car or fine details into a figure that you're going to be printing or on a wand, you know, as we showed, they have to hit a certain dimension. One thing that's beautiful with this program is to be able to not only set those dimensions, but also set the shapes. So in this case, I'm going to just set that to 100 thousandths. And let's do a square. The reason why it's doing that is because it's so low res. It's too chunky. So let's just go ahead and set that a little finer. Okay. Gotta draw another curve here. And let's do another ridge. Let's make it a little chunkier. A nice clean cut on that. And one thing that I love about this program, especially when you're doing things like cars, is that one of the hardest things to do with cars are the cut lines. Get them the perfect cut lines wrapped all the way around, or a nice sharp curve that's going to just flow around the edge of it. Well, that's where you have all your CAD drawing tools built into this. So I can go through and draw a curve, and let's go ahead and edit that curve. I'm going to do a poly edit. Let's maybe make a few other. I'm just going to go through and trim this and trim out what I don't need. And let's do a fillet between this. I'm going to do 60 thousandths. Ooh, that's not nearly big enough. Let's do a 1/4 inch. There we go. And I'm going to project that curve. And now I can go through and do a cut. So I get a nice clean cut on there. Well, we can also do other types of details. So a lot of times what I'll do on stuff, we'll do textures, kind of seamless wrap textures, or sometimes textures that have to be in a specific area of the model. Let's go around. It's always kind of fun. Go around this edge. And I'm going to run this one. This is emboss with a curve. So I'm going to select this, and then I'm going to select inside there. And let's go ahead and preview that image so we can see what it is. That is very shallow. Let's go ahead and make it deeper. That is technically to tolerance, but just for this, let's do like 65 thousandths. You know what, heck, let's go a little heavier. So you can see like actually how I can wrap around edges and everything. Coming from a traditional sculpting background, this is actually one of my favorite sculpting tools just because a lot of what it has built in is very similar to if you're working with clay. And in my opinion, if you come from that background and you want to get into 3D design and sculpting, this is actually one of the easiest programs to jump into. It relies far more on your own talent and abilities and less on the interface or the program itself. Everything here is very simple to understand. I usually think that someone can learn this program in a matter of days instead of months and be creating actual functional parts very quickly. This is the carving tools. Like I said, coming from that background of traditional sculpting where you're holding something in your hand and you're used to carving something and shaping it out and having this haptic device where, I can reach behind this tool and I can start carving into it and I can feel it. So I know it's there. I know what's going on there. It's very tactile and it feels more real. And like I said, we are making physical objects. So anything that will help you get to that, I believe, is a major plus. One of the other great tools we have here is the tug tool. So this is kind of like your move brush. And I get a bit of haptic feedback with this, so I actually get a little bit of tug and pull with it, so I can actually feel what this shape is. And just so you guys can see how these pivots actually work, the ones I was doing before get too late. So I'm going to just make a couple things really fast. Let's make another one. I already have that pivot set up. So what's nice about that, I will occasionally, when I'm working out a joint design, I'll set up a pivot for something, and then I can go through and then start manipulating the sculpt. So in this case, I'm going to just kind of pull this shape around. So let me just kind of manipulate a little bit, show you what I mean. I think it's a little bit high res for this. Yeah, that's a bit high. Let's just knock it down a bit. So I can actually start sculpting away, manipulate its location, keep working on it, put it back into its original location, and then keep going. So that way we can define a figure and its joints and its arms and its movements as we go. Okay, so questions?
Check, 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 checking this awesome box that we have here. Hello. So if you all have been here before for our Q&A, we have this little toss mic here. You can raise your hand if you have a question, and then we kind of keep a queue going. I'll start because I do have a question. You said you started traditionally. I was curious kind of what your biggest growing pain was kind of coming into this industry that you maybe had to like, was it everything that you had to unlearn, or what was just the thing where you're like, man, this is taking me forever to really kind of figure out and get through?
I think I was very lucky in that I came in right at that transition period when it was happening very naturally. It wasn't a light switch type thing. I remember, I think I was at the 2007 Comic-Con meeting with licensors, meeting with Marvel Comics, which was a whole thing. Wonderful people to work with, but very, very tight about their license because they believe in what they do. But when I was there, I met with some sculptors who were in their, I want to say they were in their 60s, and they were looking at me, this 25-year-old kid, and they were saying to me, the world is changing. It's going digital. You got to get ahead of it. Learn this tool before you get left out. So I was very lucky in that sense that it was a progressive type change, and a lot of what I was doing for the first 3 years of my career was 50-50. Half it was being hand sculpted, half it was being digital, till the very end it was easily 90%, and the only hand stuff I was doing was casting. And actually back then 3D printers were very expensive. I want to say the cheapest one you could get was about 60 grand. That was the Z-Core. It was trash. And so we would actually CNC stuff. So I would actually run a live spindle 4-axis CNC. So I would sculpt everything at that time in ZBrush, run it through voxel cam, which actually would convert it into a voxel, run a toolpath, and then cut it out on that. And then from there, I'd make molds and cast it and ship it off to be pantographed. So it was quite a different time, but I'd say by about 2009, I went full digital. That's when I started working with Freeform. I say the most difficult thing back then that you didn't have a place like Noman, as far as I knew. I didn't know where to learn ZBrush. I think ZBrush 3.1 had just come out. I had one look at it, and I was like, okay, I'm going to buy this. I'm going to sit down and torture myself until I know it. That was the hardest thing, but at no point do I think I ever unlearned anything. When you're learning traditional sculpting, this thing has to stand. You're gonna make a clay sculpt. Yeah, you got your armature bar and all that, but you got to take that thing, cast it, and if it doesn't stand, it's lying on the floor. No one's gonna buy it. So you got to know how strong is that leg, how strong is that resin, how thick is this, what is the chemistry of this? Do you have an infrastructure? So it's really just applying the same knowledge to just another thing.
Have anything to add?
I think one of the toughest things was like, I came, learned all my sculpting, a lot of it was online. Besides school, but like I did a lot of self-teaching, so trying to differentiate like what of these tutorials online like are actually good. So you had to literally sit there, watch everything, and then decide, is this a good tutorial, or am I learning the bad things, these bad habits? So I think that was the major thing. Like there's just especially now, there's so many tutorials now. Like what of them are actually good? So if you're self-teaching, I think that's the hardest part, is trying to differentiate that. But you don't have, so yeah, just didn't have a school like Noman, right? Yeah, they had to guide you through all that.
Hello, thank you for an amazing demo. It was really inspiring. I wonder the process when you're sending the file to the manufacturer. Do you need to export the file in certain file type, or do you need to lay out all the parts, like something like that?
So one thing that's kind of the best kept secret about manufacturing is Freeform is very big in most factories actually, and you can in fact design your tools within this program. One thing that I've seen quite a bit, and this probably happened, I want to say around maybe 2013-ish, maybe a little bit later. When I was first few years when I was at Mattel, we would sculpt things in Freeform, then we'd have to export it into Geomagic Studio, wrap it into a surface, run it into Pro Engineer, and then do all the work on that. And slowly became less and less and less to the point where they were like, hey, just send us Freeform, we're gonna tool off the poly. Freeform itself has a very nice high-res format that's relatively small. So when they go to bring this in, and they'll make their tools in this program, it actually has, let me just show you an example. I'm gonna go to a blank object. Let's just go to an empty space. I'm just gonna put something in here. Let's grab just a torus. That's an easy one to show this on. Yeah, let me do what I want. There we go. So if I was gonna figure out the draft on this, for example, Freeform has draft tools built into it. So that way I can actually say, you know, for example, let's first show actually what the draft is on this. So let me go down to my mold tools. I'm gonna turn on, so you can see based on that pull angle where the undercuts are, and it actually has a color here. If I want to, for example, say, okay, let's go from this current view. So these are all undercuts. So with Freeform, I can say, okay, let's, yeah, that's fine. I'm gonna just turn that off real quick so we can actually see things. So I can come here to my draft repair and say, okay, I want to go from this angle. I want a 2-degree draft. There's a little trick right here. If you don't do this, it'll make an error. And now it has draft on there. And I can not just select the whole thing, I can actually go through and actually select individual parts and do the same thing so that I can figure out that draft. So programs like this are very common, I find, in our factories that we work with. They will accept native Freeform files. We do provide STL files just because it's easier to review in STL, and you can knock it down, but one very important thing to remember, every time you decimate something, you are changing the shape of that object. You know, you can't, for example, you have a circle and you have, like, say, 1,000 points on it, you knock it down to 10 points, that's not a circle anymore. So you gotta really, you know, consider those things. On top of that, Freeform actually has modules to connect to what's called wind chill. And then a lot of tooling places will use either Pro Engineer or CATIA or I think NX for their tooling. And that can import in the really high-res models from Freeform, and they can tool directly from that. So normally we will work in Freeform and STL for review. So.
All right, yeah. And then I got you next. Anybody else has a question, you can feel free to raise your hand, and then I'll keep you in my mental queue up here.
Hi, I had a quick question about the articulation. How do you account for what is allowed for articulation and what a figure can support? Like, because for Link we just saw he can do double elbow articulation, but then for something like Homer, he has no elbow joint articulation. So how do you go about determining those design choices and what a figure can or cannot support?
I believe that the Link does have an elbow articulation. It just has in this model, I'm trying to remember, did I do a double or a single? Oh, this is, it's a double, yeah. Had me worried there for a second. So mostly what I'll do is I will look at the initial design of what we're working on, and then also look at what we want to do with it. So in this case, Breath of the Wild, every time you see an image of Link in Breath of the Wild, he's in a very dynamic pose. He's holding that arrow out. He's in that pose with his Master Sword. I want to be able to do that pose. So that's where I'll look at the model and say, okay, where can I cut this up cleanly and have these articulations so that they can do these poses and the end user can truly enjoy it. And so, for example, on this one, you see how there's an arm spin right here in the shirt sleeve? Well, and for manufacturing reasons, that had to be 2 different plastics because it's different colors. That's a freebie. That means that I can actually design a socket right into here, which let me go ahead and turn off this upper one so you can actually see that. See what I'm talking about. Yeah, let me turn off paint. It's always easier to see it without the colors on there. So I have this socket built into there because it's a free one because you have to do a color break for different plastics. So that's what I'm usually looking at whenever I go to do an articulation of a model. You know, what type of articulation is it? What type of poses is he going to do? And then where can I do the nicest, cleanest cuts that, you know, meet the type of poses that we want to do with it?
Okay, so I have a question about your traditional digital background. Is it easy to go from traditional to digital mediums?
I personally think it is. And of course, I definitely would like to hear Lisa's point of view on this as well. But so for me, it was, and this is something that I know I drive people crazy on digital artists. I always tell them when they're holding something, when they're working on a head, specifically, turn that head this way, look up the bottom from the chin, because faces aren't flat. And if you sculpt something from just a perfectly flat view, it's not going to look right. But when you're sculpting something by hand, you know, just because the way our eyes work, we see dimension all the time, unless you're blind in one eye. So you're going to be seeing that, and you're naturally going to be making things more dimensional, more, in my opinion, realistic. So I do think going from digital, from traditional to digital is easier because you have that background. But that is also just my experience. Lisa, what do you think?
No, I agree though. The thing is, I didn't have any traditional, that kind of traditional background. I literally just went straight to ZBrush from just digital. But I do think that having some kind of tactical, feeling the clay out, doing that kind of stuff, because I, instead of doing I guess that kind of traditional, I did life drawing and all that stuff. And I think that helps build your art overall, not just sculpting, and it helps make you learn don't get stuck on looking at one angle. Look at all angles. So I kind of treat sculpting in ZBrush kind of as close as I can to real life sculpting. So yeah.
Hi. First off, I just want to quick say I'm also a bachelor's in psychology. I am switching, careers, so I'm teaching everything myself too. One of the questions I had, it was kind of a two-parter. So with this program, you're showing a lot of articulation with the models. Is that, I guess, is that something that would be approachable from an independent standpoint? If you were to be making your own, is there ways to print it, or is there ways to make it without having to work through, say, Jakks or Mattel or some larger studio?
So if you were doing your own small run, like toys yourself?
Yeah.
One thing I suggest for all digital sculptors, or even anyone who's moving into digital from traditional, buy a 3D printer. You can get them for $100-something on Amazon, free delivery. They are amazing. The $100 printers are going to work as good as the $200,000 printers. They print so well. And you can actually design your parts for assembly and everything in that method and do your small run. And I tell every sculptor I meet that's learning, get a printer, print your designs, have a look at them in your hands, especially if you want to be in toys, because you need to see what actually shows up, what actually looks good, because oftentimes what you see on the computer isn't necessarily going to look quite right when you hold it in our hands. A lot of things that I do, we'll print, we'll look at it, we'll review it, say, you know what, this really should be a little bit more here, or a little more there, and then we'll kind of do it again. When you're looking at something like this, this close and everything, but this model is 5 inches tall. Let's see if I can get him up to 5 inches over here. That's roughly 5 inches. So it gives you an idea, like, you really got to print these things out, really look at them. And if you want to do like a small run production, it's actually very easy to do with 3D printers today.
Where do you see toys going in general? We've seen, you're just talking about the rise of sort of 3D printers and software, and even in the world of soft vinyl, you're seeing a lot of sort of cottage industry toy makers popping up. Do you see that as a trend happening in toys on a bigger level? And especially, I hate to bring this up, with tariffs and becoming more of a factor working overseas, are there going to be more sort of print farm manufacturing things happening?
So as far as the manufacturing side, I mean, stuff to do with tariffs and that stuff is frankly just beyond my understanding to be able to say anything of any value. But as far as on the manufacturing side with 3D printing, it has had an amazing influence and made a lot of great changes, because back in the day where we would work back and forth with our engineers all over the world, wherever they are, now we can do essentially a 3D fax, and they send files back, we'll print it out, we'll look at it. On the manufacturing side, I don't think it's ever going to be really rapid manufacturing. That's what they call that when they 3D print stuff. On the toys, for the reason that the type of plastics that we use are not, in my opinion, ideal for this type of interaction. Toys, 3D prints are, they're polycarbon chains. They're plastics that have to be assembled, and they're being assembled through a chemical process with that light that hardens it, or it might be heated through an extrusion, and that creates a bunch of layer lines and stuff like that. Toys have to be a bit durable. Kids are going to be playing with this, people are going to be playing with this. Last thing you want is that to break, or for the plastic to break down, because it doesn't make a full polycarbon chain actually. It slowly turns either to liquid or to dust. But one thing that I've seen has been really great as far as the way toys are going, in my opinion, that I've seen the past 20 years, is that when I was like in my teens, if you were looking at toys, in that age, they're like, what's wrong with you? And then Todd McFarlane came around and he changed everything. I really got to give that guy credit for McFarlane Toys. It changed the world. All of a sudden you started seeing toys that were just beautiful sculpting, and there always were these amazing sculptors there, but they just never really put their great stuff out there until after McFarlane. And then you saw everyone starting to do this higher level toys, and then as everyone kind of progressed, now it's been 20-something years, people want to buy art, they want to buy something they like, whatever it is, they're going to buy that vinyl toy, or they might buy that very high quality figure that they love, something that for them, that is their art. So that's kind of where I see that. You have, of course, kids that are growing up and loving every bit of it, and then you have the adults that are also loving it. And I think it's a great trend that's going. I don't know where that's going to go. I think it's kind of similar to comic books. They kind of go through their phases up and down, and hopefully it keeps going up. I said the interesting thing about COVID was, it's kind of like the idea that your mom catches you smoking, and she's going to make you smoke an entire carton. Apparently, if you force kids to look at a screen all day, they don't want to touch them anymore, and so they start wanting to play with toys again. So it's, interesting how things go. Lisa, do you have some thoughts on this?
Not really. Because I feel like I'm not in the industry long enough to figure out like what beyond what's more into toys right now. Toys are toys and they're fun, and I feel like we should play with some toys. Yeah.
Hello? Oh, hi. I had a quick question about kind of, I guess, like the sculpting the anatomy of the toys you design. Like when it comes to, say, joints and sockets, like where does that knowledge come from? Is it a thing like kit bash and taking things apart, or is there like an industry standard to modeling those?
I'm sorry, to working with kit bashes?
Oh, sorry. I mean, like, so for the link example you have up above, there's, say, some of the sockets, some of the joints you showed us. Yeah. How do you know what shape to make those? Like, is there sort of a standard you start to pick up? How much of that it comes from just working the toys up over time? How do you know where to start on that?
What do you think? I'm so sorry. I think you have like a really good question.
Well, I think that generally kind of what they're getting at is this link figure and all figures that you work on, right? What is the baseline for your joints? Like when somebody gives you like a Spider-Man, you go, okay, they want it to be articulated this way. I know it needs this many points of articulation and they have to be these kind of joints.
Oh.
Is that just from doing the toys from a certain amount of time, or is there like a template like every Spider-Man always has these joints no matter what it is, right?
What we're going to look at number one is going to be scale, because that's going to define a lot. If you're doing a 10-inch figure versus you're doing a 4-inch figure or a 2-inch figure, those wall thicknesses and all that stuff come into place, because you're not just thinking about how thick is that wall of that body, you're thinking about how thick is this this cylinder right here that shoulder is going to be rotating on, and the pin that this is going to be spinning on. So let me just turn off this chest so we can get a look at it. So you see it has these pins in here, right? And these have to be assembled. Well, you have an arm like this. This is a fulcrum, and you get that arm stretched out, and you turn it the right way, it's going to pop that socket right out, or it's going to break, and that's the worst possible thing you could have happen to a toy. Not just for safety issues, it's because in my opinion that's not just a good toy. So scale's number one. So looking at, for instance, a 2-inch scale, I have to consider how am I going to split these joints in such a way that those wall thicknesses are going to be big enough that they'll hold, and then also how are they going to be able to keep that pin to be able to rotate around to move, and what type of rotations can I get based on those dimensions. So I'd say start always with scale. I do a lot of work not just in this program but also in ZBrush, and the very, very first thing I do when I start sculpting is I make a box and I set that box to my XYZ scale of what that model has to be. And I know this because working in toys, we know, okay, we have this size figure, it's gonna be roughly this big to fit in a package, so we'll go from there. And from that point on, then I'll start figuring out where those joints can be.
Hi. That's a lot louder than I thought it was gonna be. So this is the first time I've ever gotten to see the Freeform like roto thing in action. It's really cool. I guess my question is, since it's a pretty specific tool, when you guys are looking to hire for somewhere in the toy industry, what kind of skills maybe are you looking for that aren't just like software technical, but something that sets it apart from just a regular sculptor?
So one thing I'll definitely say, I think I've been very fortunate to meet people with such great talent early out of school, and I've had a number of people I've worked with and in the same position, and normally what I'm looking for is certain qualities of their sculpting. I don't hire someone because they know how to press buttons in ZBrush or in Maya or something like that. I'm looking for someone who knows how to sculpt. And in toys specifically, like I said, there's no cheating. You can't do simulated clothing. You can't do X-Gen hair or texture maps. So I'm looking at somebody's work and I'm seeing, did they sculpt the hair? Did they sculpt the clothing, or did they do a simulation? Or, when they did the certain details on the face, they could have done a texture map. Did they actually sculpt it? That's what I'm looking for. Someone who never saw a problem they can't sculpt their way out of.
Oh, awesome. All right, everyone, give it up one more time for Eleazar Kim-Carmeli, Lisa Hong, and Jakks Pacific. Thank you all so much for taking the time. Of course, you all stay around. We got some awesome stuff for you, and thank you for tuning in at home. If you're curious on what Gnomon can do for you, go ahead and give us a look at gnomon.edu. You can also send an email to info@gnomon.edu. And until then, we'll see you all next time. Thank you all so much.